All right, welcome back to geometry class. Again, I hope you did well on your homework and that seeing the solutions worked out for you as you reviewed it helped answer any questions that you might have. If it didn't, please go ahead and keep track of those that you had questions on so that when I come back, we can get those answered. But let's go ahead and look right now at lesson 102 on page 663. We talked yesterday about secants and tangents and that they're products, the external to the whole, from the external point to the far point, their products equaled each other when they had that same external point. Today we're going to be shifting gears and talking about dilations in a coordinate plane. Now a dilation, remember, changes the size but not the shape. It's going to be a similar figure when we're finished. So if you do a dilation and it looks completely different, you go from a triangle to a rectangle, a triangle to a square, then that's just a tip off that you have something wrong. But on a dilation, we're going to be using some with matrices and some with single points here. This multiplication we will do today much easier than the matrix multiplication we learned the other day. So let's look at the basic transformation mapping for a dilation. It is going to be tipped off for us by the letter D for dilation. We're going to have an O here, and that O stands for origin. These dilations we're going to be doing are going to take place from the center point of our origin here. They're going to be originating from the dilation place of our origin. The next thing, there'll be a comma after the O for origin, and this is going to be represented here by K. It's actually going to be a number, but this K here represents our dilation factor. It's a lot like a scale factor in that we're going to multiply it to our points here. We have our points XY that will be listed. Our arrows showing that there's going to be a transformation taking place here. And our new point is simply going to be X times K and Y times K. Again, much like a scale factor, we're simply going to apply that dilation factor to each point, multiplying it to each point. So let's look at an example of that. If I had a dilation with a dilation factor of 3, again, we're taking that from our origin here. We're going to simply multiply 3 to each of these, the X value and the Y value. 3 times 3 is 9. 3 times 4 is 12. There's my first point. We're actually dilating a line segment here. Here's my second point from the line segment. Again, I'm simply going to take my dilation factor and multiply it to every term here, to my X and my Y. 3 times -1 is -3. 3 times 5 is 15. It's very simple when we're using a dilation factor on a simple point here. And again, this was representing a line segment that we were dilating. And we get the point 912 and -315. If we were going to dilate something larger, such as a triangle, as we see in example 2, then a matrix is actually going to be a tad bit easier for us. Remember, this is my X value, this is my Y value, this being a single point here. This is one point of my triangle, this is another point of my triangle, this is the third point of my triangle. If we had a quadrilateral, we'd have one more. If we had a pentagon, we'd have 2 more, and so on. This time, when I'm taking my dilation and I'm told that it's by a scale factor of 5, I am simply going to multiply this 5 outside of my matrix. Again, this is my scale factor here, multiplying to my matrix. Different from what we did the other day, much easier. I am simply going to multiply 5 by every single point, just like we did up here except this time it's organized in a matrix. So 5 times 3 is 15. 5 times 4 is 20. 5 times -2, -10. 5 times -1, -5. 5 times 4, 20. 5 times 7, 35. These are my new points. These are my new points. Remember, this is X and Y. So my new point is 15, 20, -10, -5. And my third point is 20, 35. Thankfully, they don't ask us to graph this because that gets a little large getting all the way up to 35, even 15 or 20. They don't ask us to graph it. They just ask for the new coordinates. The new coordinates. And it's very simple to multiply a dilation factor or a scale factor here to a matrix. We're just simply multiplying it to every single term inside. Every single number inside. Let's look at example 3 now. Example 3, they give us a little bit more complex of a problem. They're asking us multiple things. They're asking us to not only take this picture, which they said is a scale factor of 1 inch for each segment here, but they're asking us to take this and to dilate it by 2.5. So we're going to take 2.5 times each of these points here. This original picture is a 3 by 5 picture, and again that's in inches, a 3 inch by 5 inch picture, and we're going to determine what our new picture will be when it is dilated by 2.5. Very simple at first. 0, 0, 0. 3 times 2.5 gives me 7.5. 2.5 times 5 gives me 12.5. 12.5 and 7.5 and 0. I can see here that my coordinates, starting here at my origin, going over 12.5, going up 7.5, this is my X, this is my Y, that the coordinates for this would be 12.5 by 7.5. This problem asks me to compare the area of the new picture that I've dilated here, and they're also wanting me to add a 2-inch mat all the way around, a 2-inch mat all the way around this picture. So not only do I have this picture, but I also am trying to find this area, much like we did the annulus, but they're wanting to know just the area of this mat, just the area of this shaded green area. To do that, just like we did the annulus, I should find the area of the total figure and subtract out this red area, and subtract out this red area. Again, much like we did with our circle with the annulus. So we have this 12.5 by 7.5, which is the red area, which we could cheat here and see your book gives us as an area of 93 7/75 of an inch. We're going to add 2 inches here. That means we need to go down and over 2 inches. Down and over 2 inches. Over and up 2 inches. Over and up 2 inches to get this full mat area, giving us a new dimension here that goes 2 beyond what our original dimensions were, which were 12.5. So if I'm going the 2 inches beyond that, my new dimensions are 14.5 by 9.5. 14.5 by 9.5.